had section 2.2.4 called dimensional analysis. So if you could turn to page 22 in your core packet, that would be awesome. And for question 76, it says, in the big race. So we finished up the big race yesterday. Leslie rode at a rate of 2 meters every second. However, you want to know how fast she was going in feet per second. All right, so we had meters per second, and you want feet per second. Okay, so slightly different. So what you're going to do is you're going to refer to this math notes box in the lesson for equivalent units of measure. So you're going to see these type of questions come up in both the core packet and in the homework packet, where you're basically converting, you're changing from some units to different units. Okay, so we're going to talk about how to do that. Below are some commonly used conversion factors, metric prefixes, and abbreviations. All right, so for instance, 1 inch is approximately 2.54 centimeters, 1 foot is 12 inches, 1 yard is 3 feet, 1 mile is 5,280 feet, and so on. So some of these you're going to be like, yeah, I've heard that one before. Obviously, you should know that 1 foot is 12 inches, right? Most of you know that. You can write that as a ratio. Ratio is a fancy word for a what? A fraction, okay? So when you write it as a fraction, you can put 1 foot in the numerator and 12 inches in the denominator, or you can put 12 inches in the numerator and 1 foot in the denominator. You can write it either way. Why would that matter? Well, it's how they want the answer. For instance, here they ask you for feet per second. Okay? They want you to ultimately get your answer in feet per second. So you might want feet in the numerator, you might want feet in the denominator, you might want inches in the numerator, you might want inches in the denominator. It's just going to depend on the question and how it's going to work for you. It's the same ratio, bless you. It's just going to get you the answer that you want. Okay? So here's how it works. In the big race, Leslie ran at a rate of 2 meters per second. So I started by writing down what she did. She ran 2 meters for every 1 second. Okay? And then I realized, okay, we want to determine the rate in feet per second. So right now I got meters, I want feet. So I went over to the chart and I found feet, and the only equivalent it has is inches. So I wrote 1 foot per 12 inches. I could have written 12 inches per 1 foot, but the final answer, we want what to come first? Feet. So I wrote feet in the numerator and inches in the denominator. But then I realized, okay, inches is not going to be in the answer. So I need to look for inches in the chart. And it just so happens to be the very first one. Okay? So I've got 1 inch equal to 2.54 centimeters. So I wrote 1 inch to 2.54 centimeters. And again, I could have flipped it, but I need the inches and the inches to cancel, right? So I left it in the numerator. Then I realized, okay, I want the meters to cancel out. So I needed to just be left with feet instead of meters. So I found one more conversion, and this one is down in the chart below. So look down in the chart, and you want to find centimeters. So here's the centimeters. See it way down here? And it says 1/100th. So I could have either written 1 meter is 100 centimeters, but I wrote 100 centimeters is 1 meter. Why? Because I need the meters to cancel with the meters. okay? It just depends on what you're going to want to cancel it with, okay? If I have this meters in the numerator and this meters in the denominator, I can make what they call the big one. Basically, they'll cancel with each other, okay? So once you've written out all of your fractions, the next step is to collect all of the things that you need to multiply numerically in the numerator. So I have a 2, I have a 1, I have a 1, and I have a 100. Do I need to write the ones? No, because anything times 1 is itself. So the two important numbers are the 2 and the 100, right? Okay. And then looking at the denominator, I have a 1, a 12, a 2.54, and a 1. Again, the ones don't need to be written because anything times 1 is itself. So the two important numbers that I'm going to need to multiply are 12 and 2.54. Okay? So I'm going to, in the numerator, multiply the 2 and the 100, and in the denominator, the 12 and the 2.54. Everything else I'm going to try and match up, right? Because the meters and the meters matches up. The feet doesn't match with anything, but the inch and the inch match up, and the centimeter and the centimeter match up. So what I'm going to be left with is going to be the feet per second, which is how they want our answer, right? Feet per second. So watch this. I grouped the 2 and the 100s together. So from the numerators up here, I got the 2s, the 2 and the 100. And in the denominator, I got the 12 and the 2.54. And then I made what they call giant ones with the meters. They're going to cancel with the inches. They're going to cancel with the centimeters. They're going to cancel. And I'll be left with just the feet per second, which is how they want our answer. Feet per second. So then I grab my calculator and I can multiply 2 times 100 in my head, right? Get 200. Multiply 12 times 2.54 on the calculator. I got 30.48. And I've narrowed it down to feet per second already. Then I just do one more calculation with my calculator. 200 divided by 30.48. And I rounded to 6.6. 6.6 feet per second. So if you punch that in your calculator, you're going to get the same thing. And then I just double check. I wanted my answer in feet per second. I've got feet per second. Okay? So you're going to refer back to this calculator and make the proper conversions based on what you start with and where they want you to finish. They're going to give you units to start with, and then they're going to tell you the units they want you to end with. Okay? So you need to look on the chart here or look on the charts down at the bottom and see which one they're looking at. All right? Let's talk about page 23 together. This one's called a snail's race. Okay? Let me shrink it just a tad here. All right, volunteer to read that top paragraph, starting with Terry. Volunteer to read Terry.
Terry, Madeline, Matt, and Olivia were working on a different rate problem. They were preparing for the unfinished snail race, and they were thinking they could travel up to 8 feet per hour. The snail race lasts only a few minutes, so they want to know how many inches their snail could travel in 1 minute.
Thank you. Okay, so what did the snail, what do they know the snail could do? 8 feet per hour. So circle it or highlight it. 8 feet per hour. That's what we're starting with, right? Okay. And they ultimately want to know, and they're always going to give you a goal to get to, how many inches their snail can travel in 1 minute. Okay. So we're starting with feet. We need to get to inches. We're starting with an hour. We need to get to minutes. All right? So Madeline spoke up. I know there are 12 inches in a foot. Yes, we all know that. It's on the table, but most of you don't even have to look at the table for that one, right? And 60 minutes in 1 hour. But I always get mixed up about when we are supposed to divide and when we are supposed to multiply. Help. Olivia chimes in. She says, do you think we can try using ratios so that we remember when to multiply and when to divide? Let's list out everything we know, okay? So you can look at the conversion chart. We know that we want to start with 8 feet per hour because that's given to us in the problem. But I wrote or, okay? Or you could write it as 1 hour per 8 feet. Technically, the way it's written, you can go either way. And then you can say 12 inches to 1 foot. You get that right off the chart. Or you could write 1 foot per 12 inches. And then as far as time goes, we know you can use 1 hour per 60 minutes. Or you could use 60 minutes per 1 hour. So you have some decisions to make, right? Okay. Madeline exclaims, I got it, and shares her work with her group. She says that 8 feet to 1 hour and 12 inches to 1 foot is 96 inches per 1 hour, right? But what happened here? How did Madeline compute the 96? She just multiplied the 8 times 12 and got 96. Okay, but did she get to the correct answer? Because she's got inches per hour. How did they want us, if you look back up here, how did they want us to get it? To inches per minute. Okay, so she's not quite there, right? All right, bless you. Olivia says, bless you, I think you are onto something, Madeline. Like, she's got a good start, right? Okay. We know that 1 foot is equal to 12 inches. So we can make a giant 1 out of that ratio. Since we already know what multiplying by a giant 1 does not change the value. Let's multiply the snail's rate of 8 feet per hour by a giant 1. Olivia shows her the work. 8 feet to 1 hour, 12 inches to 1 foot. That makes a giant 1. Hey, that's cool. Now we can rearrange like we did, and we use the giant 1 with the exponent. So you've got 8 to 1. You maneuver the feet together. They're going to cancel. Okay. We've also got 12 inches in 1 hour. So we get a rate of 96 inches per hour. Why can Matt rearrange the terms? Why can we move them around? Because order doesn't matter with multiplication, right? 3 times 5, you get 15. 5 times 3, you get 15. Anybody know the name of the property that allows you to do that? Yes, good job. Commutative, good. All right, so let's try it. Terry is concerned because they only know the snail's pace in inches per hour when they need to know the pace in inches per minute. What is the snail's pace in inches per minute? So they were really close, but they need to take it 1 step further, right? So we're going to take it 1 step further and go 19 inches per 1 hour. 1 hour is 60 minutes. We're going to take the 96 and divide it by 60. If you punch that in your calculator, here's what you get. You get 1.6 inches. The hours cancel, and you're left with inches per minute. Okay? Finish copying that down. So you guys are going to try some in your group, and you're going to need to refer back to that chart, okay? Chart on page 22, you're going to have to flip back, turn your page, look over at it. You're going to get through page 20, I think it's just 24. It's going to talk, you're going to do problem 78, 79, and 80, okay? If someone in your group has not picked up the folder yet, send someone to grab a folder. Turn your desk so that they're facing each other. I'll move this up in case some of you are still copying that down.